Lecture 13 deals with dyes and prints. So we're looking at how we add color to fabrics and textiles and fibers. This first section will mostly look at dyes, and then we'll look at using pigments for prints in the next one. Color is really a significant factor in how we put textiles together and how they're used. Each season presents a new opportunity with color. And until 1856, all dyes were natural. But after that, in conjunction with the Industrial Revolution, the first synthetic fiber color or dye was made in mauve. The goal is to find an appealing color at the right price with minimal environmental impact. Color fast dyes do not fade or change in exposure to light, use, or care. So adding color is really challenging. For fiber chemistry plays a really strong role in this. Your fiber chemistry has to match your method for applying color. We know all fibers are made up of different materials and act differently. And so dyes and fibers must be compatible. A fast dye, or a dye that lasts over time or that is color fast, is permanently attached within the fiber. So we've talked about different stages of dyeing. I want to make the point that the farthest stage away from the consumer is a fiber dyed stage. And so these are early decisions that a manufacturer would be making about color. One of the best examples that we've talked about previously is tweed, where you have different fibers that are put in a yarn. So that's a decision that's made really early on in the process. There's also another fiber decision would be solution dyeing. We talked about putting color in the dope of manufactured fibers. Well, that's a really early decision you would make on color as the fiber themselves were being manufactured. And then we have, throughout the semester, dealt with yarn-dyed fabrics like gingham. That's where your yarns are colored and then used in fabrics with a structural design. So this requires some yarn inventory and some time to thread, especially woven fabrics, to thread them in a loom and create that structural design. You can also make decisions at the fabric stage. This is less expensive than fiber or yarn dyeing, and you can delay your color decisions. When you make these decisions, dyeing decisions at the fabric stage, that's often called piece dyeing. Piece, like a piece of paper. The latest dye decision you can make is at the garment stage. So you can dye a garment or a product when it's fully sewn together. You may have had an experience with this by doing a tie-dye, a very cheap kind of process that you put on the final product. Tie-dye also presents one of the larger classes of dyeing that we call resist dyeing. So tie-dye is a type of resist dyeing where, if you've ever done it, you know you tie up sections of the garment with rubber bands or something that will resist color, and then you dip it into color, going from from light to dark. We have a couple of general classes of dyes. Union dyes are dyes that create a consistent color. So when you put a bolt or a roll of fabric or a piece dyed kind of material into these dyes, many of these bolts are blends. So you'll have a cotton poly type of blend, whether it be a t-shirt or a piece of textile. When you put a blend into a union dye, it turns a solid color. And so you can have two or more generic classes of fibers that accept dye differently, and a union dye will turn it all one color. Cross dyeing is where you have two or more generics. So you have a blend or mixture of fibers in your garment or your fabric, and it creates a heathered color. And so in cross dyeing, the dye is accepted differently by that blend. So they're absorbed differently by the cotton, and it turns the polyester or the other, you could have a spandex in there, any kind of manufactured fiber. And it has this kind of yarn dyed appearance to it. This is where you get heathered type of fabrics. Synthetic dyes are chemically synthesized. They are cheaper. They're used very widely. Most of what is used today to put color into fibers and fabrics is a synthetic dye. They come in a wide range of colors, and they're great because they create a consistent result from batch to batch. And so you can make large amounts of product and have it be consistent across dye baths. There's all kinds of synthetic dyes that you see on the left, and these are typically classified by the method of application that you see. On top there are the first four are kind of grouped together because they don't take any kind of pre or post treatment. They're all water soluble dyes, and so they use water to be applied into products. The difference comes between these classes is what they're most effective at dyeing. So you can look at the details of these in iTextiles. I'll give you some thoughts on them. Like I said, the first part are water soluble, no pre-post treatment types of methods. And then the last four require some kind of pre or post or special type of treatment to be held within the fiber. Acid dyes were originally used to dye wools and silks, but they are the most commonly used dyes now for nylon and protein type of fibers. Not cellulosics, because we know cellulosics are damaged by acids, but they can be used for nylons and proteins. Azoic dyes are minor dyes used in small amounts. It's more of a minor category. We'll talk about batik in a minute. Azoic dyes may be used in batiking processes. Basic dyes are your oldest groups. Now they're used for acrylics primarily. And direct dyes are your least expensive. They're often used for cellulosics. The next group, the ones that require some kind of special treatment, the dispersed dyes, for example, are water insoluble. So they're dyes that have to be delivered so that they go into the fiber and hold on to it. So they're water insoluble, and they're used for manufactured fibers. And you remember manufactured fibers don't take in water very easily. And so these class of dyes were developed for actually hard to dye fibers like acetate. Reactive dyes have to create a chemical reaction and form bonds through that chemical reaction within the fiber. Your reactive dyes are actually some of your more eco-friendly type of dyes. I don't have listed on here certain type of azo dyes. We do monitor dyes for their health and environmental impact. Of course, they're chemically made, and so they do have impact over time, but there have been dyes that have been banned in the United States and Europe because of those reasons. And then, of course, there's natural dyes that are found in nature. They tend to have limited commercial value because they're really hard to get large quantities of them to scale. And it's an agricultural product. It's hard to understand how we might take some of these and do them at a commercial scale. But they're used in niche markets. When I go to Guatemala, there's a lot of producers making product, a significant amount of product using traditional textile techniques that use natural dyes. And of course, fiber artists use natural dyes very frequently. One of our associate dean, Roland Ricketts, uses indigo as a process to make some of the art that he displays internationally. Natural dyes do take a mordant, what we call a mordant. Mordant is something that prepares the fiber to receive the dye. So there has to be something that helps the dye hold into the fiber. And these mordants, some of them are more environmentally friendly than others, like alum and iron, whereas if you're using chrome or tin or copper, those would be more toxic processes. Indigo is a dye that can sit on the surface of a yarn. It doesn't absorb really well. And so, as you know from your jeans, as it wears, you can see the lighter colors of the fibers underneath. And you get these acid or stone wash effects by manipulating how indigo adheres to products. Distressed denim, or getting these marks on products, has classically been a really labor-intensive type of process. So you can see how distressed denim are they're really trying to put holes in the fabric rather than just rub away the dye. So you're actually destroying the product for the fashion look, but you can see there's a lot of fashion waste with it as well. But also, this is why, because it is so labor-intensive and wasteful of a process, this is why we have companies working to find more environmentally friendly ways of dealing with distressed denim. Let's get past this ad. And you can see that technology is being developed to actually laser treat jeans in a more efficient manner that can have a similar kind of look. And this shows one look. There's a lot of different types of laser processes they're working on. So distressed denim is also what we would call an aesthetic type of finish. Here we're talking about how we affect a dye in the process, but it's also considered an aesthetic finish.
So you see how the rip is so good, like, oh my god. And then this one, and you see how washing it really brought out like the...
Let's get rid of that. Go back here. So another resist dye method is called ECAT. This is where the yarn of the fabric, so you see in the upper right that this woman is working with warp yarns that have been stretched out. And she's wrapping areas of the yarn to, like your tie-dye, to have it resist being dyed when put in a dye bath. So it's a yarn dyeing process where areas are wrapped to resist. Frequently this is done in warp yarns. It doesn't always, it can also be done in filling, it can be done in both directions. But you wrap these yarns and then you weave it together. And it takes a lot of skill to match the yarns and to have the pattern reveal itself as it's being woven. But you get these shapes that kind of have fuzzy edges to them in an ECAT. A true ECAT is a really labor-intensive process, but of course ECAT can be printed and in many ways distributed less cheaply. Batik is another type of resist dye process. This is a hand process where hot wax is applied onto a design, and then each fabric piece is dyed progressively from lighter colors to darker colors. But the fabric, it takes a particular dye to be able to do this, because you dye it in a cool bath, and so the wax doesn't melt off the fabric and it continues to resist. And so you can get really elaborate, colorful fabrics, but it's a very consuming hand process, time-consuming hand process. So just looking at dyes, what I want you to take away from this is to understand the nature of dyes as something that's typically delivered with water. And we're going to talk about pigments next, and so be able to compare pigments versus dyes and how they're used. The stages of dyeing and what implications that has for the consumer and the manufacturer, the difference between union versus cross dyeing, and the difference between synthetic and natural dyes.